.NET Data Access with Frans Bouma.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your humble host. Make sure to check out www.azuredevops.show for past episodes and show notes. And we're still processing the announcements from the Microsoft Build Conference. There's a lot of great stuff there. I'm particularly excited about the Blazor announcements. And there's so much more going on in Azure and Studio. So if you haven't seen all of the recorded video content from the virtual build event, make sure to go and check that out. And I've personally been doing a lot of speaking at virtual meetings of user groups. And if you run a user group and that's now doing virtual meetings, I'd love to speak at your group event. If you're tuning in for the first time on the podcast here, this podcast is for developers shipping software with Microsoft technologies, and we go wherever that leads. And my goal for all development teams is for them to be able to move fast and deliver quality and run their systems with confidence. And today on the show, I have a longtime colleague, Frans Bouma. He is the lead developer of LLBLGen Pro, which is a market-leading entity modeling and object-relational mapper for .NET, and his specialties are C#, .NET, software engineering, architecture, databases, and data access technologies. Frans has been writing software professionally since 1994 and is a well-known expert in object-relational mapping, in data access technologies, and in entity modeling. So it's my pleasure to have you on the show, Frans. How are you, sir?
Oh, thank you very much for having me. I'm great. Thank you.
Fantastic. Well, there's probably a lot of listeners on the show who might have been born after you started working professionally, but either way, don't know the depth of the background that you have. Would you mind just catching them up? There's some people who follow you already, but for those who don't, catch us up. What's your journey been leading to what you're focusing on now?
Well, I started data access code back in 2002 on .NET when 1.0, when it was just released. And Microsoft had a system in Visual Studio, which is still in there today. It's called type datasets. And it was basically meant to talk to store procedures. So you had store procedures in your database, and you mapped your typed data sets onto the result sets of the store procedures. And you could also map commands like insert and delete and update to store procedures for those typed data sets. Mm-hmm. My illusion back in the day was, oh great, I can generate the store procedures from type data sets that I design myself, like a model, for instance, at the abstraction level of NEOM or ER model. But I was completely delusional because I first had to write all the store procedures by hand and then map the type data sets on them. So it was really just not helping me in the work I had at the time for a large customer management system. So I thought, well, why not write a generator for the store procedures? Because if I have tables, I can just write basic CRUD store procedures for them. Mm-hmm. And it was a great way to learn C#, the new language at the time. So I wrote a tool called LLBLGen, which is short for Lower Level Business Logic Generator. At the time, I thought it was cool to name it that way. Now it's still unpronounceable, but it basically checked which tables you had in a store procedure schema, in a SQL Server schema, and it then generated basic CRUD store procedures from that. Mm-hmm. And it was very popular in a couple of months. I think maybe 50 or 60,000 downloads or so. It was, and people asked me all kinds of things to add to that. And I thought, well, why not do that, but in a commercial version?
Oh, sure.
So when I started with the pro version of that store procedure generator, I basically had the vision of generate an entity model at abstraction level of the ER model, and then generate tables and store procedures from that. After 8 months or so of development, I basically hit a big wall, because generating store procedures from a DSL is pretty complex. So I couldn't finish it in time. So and then I started reading what the other system that was pretty new at the time, in Hibernate, what they were doing. And it was called object-relational mapping. And I thought, well, why would you generate SQL on the fly at runtime? And then I thought about a bit more, and I thought, well, it makes sense. Why pre-generate store procedures, which can really bloat your schema after a while? Why not generate the exact statement you need at that moment? So I basically threw half the code I had away and started writing a runtime that generated the SQL at runtime. And that was released in September 2003. And from that date on, it was actually a success, because a lot of developers were waiting for a tool that could point them to a set of tables and generate classes for them, and at runtime generate SQL for them based on queries they defined in a typed manner. Like today we have LINQ, but back then we had a typed query system with objects.
Right. And then that era, and for developers who've inherited a really old SQL Server database, and they see, it's like, man, why do they have all these tons of stored procedures? There was a time when we couldn't get the proper performance out of a SQL statement generated by the application, and you could only get the performance if you put it in a stored procedure and it was compiled. And so that time is gone, but we still see databases with these huge stored procedure layers because of that heritage.
Yeah, and protective DBA on top of them most of the time that will protect his database from anyone who points even a finger at it. So nowadays, I think it's pretty accepted that you have an OR mapper and that will generate queries for you at runtime. But back then, it was really a no-go area for most companies.
It was a radical concept.
Yeah, definitely. So back in the day, I'm talking about 2004, 2005, we had a couple of products alive back then. Entity Broker, maybe if you remember it.
That's old.
Wilson Aware Mapper and Hibernate. And Microsoft had Object Spaces in the works. It's a prequel of Link to SQL. Object Spaces was never released, I think, but it was a very competitive market back then because it was very new and everybody was talking about it. Most debates were very heated also about on the edge of store procedure versus dynamic SQL, and of course, which product would you use back then? But after a while, that died down, and it became more mature. The applications became more mature. Some tools died off, and I started adding more features to my own system. And from version 3, I think back in 2010, I added model first development. So you can also define your model at the abstract entity model like you want to, and then generate the tables and the classes from that. So you have one source of truth for both sides of the gap you want to bridge with your OM mapper.
So if we fast forward to today and developers just saying, hey, I'm going to start a new application, how should they be thinking about data access in .NET today? What is the modern scene?
Well, you have a couple of camps now. Some people think in objects stored in a database. They will probably go for MongoDB or likewise databases, where you have a denormalized set of objects stored in a database in some form, JSON or JSON. You have another group who thinks in messages and events, and they basically say, well, we store only the changes we record in our application, and we store it in a sequence, and at episodes in time we project them to a state, and then we can use that for querying. It's called event sourcing. And we have another group, the largest group, basically, who still say, well, we have a relational database and we have objects, and somehow we have to store the data in the objects in memory into the database, and vice versa. We have to pull it out of the database and into our objects in memory. And that third group is basically where the ORM mappers like Entity Framework, LLBLGen, and Hibernate, Link to SQL are living and used in, basically.
Okay.
And actually, the if you think about the entity modeling, like for example, you have a customer who has orders, and the order has order lines, and an order has a product. You can describe that in an abstract way, and if you project that onto a relational schema, you get tables. If you use inheritance, you can of course more tables than you have entities. But let's say you have those 4 entities, and you get those 4 tables. And then you can make a projection of that model to a denormalized model. For instance, you have an order, and you want the company name of the customer it relates to into that order. Mm-hmm. So you place that information element as a duplicate into that order element, and then you store that into an object database. It's actually the normalized projection of your relational model. So it's actually related to each other, even though they don't know it. But that's sometimes the beauty of those debates. Some people say, well, no, I want to use Mongo. No, I want to use a relational database. Well, actually, you talk about the same thing, but at a different level of abstraction and projection.
Mm-hmm. Right. So there's so much, so many options these days, especially with Azure coming out with Cosmos, and you got
yes,
and then you got queuing, which messaging is kind of like you're storing a little bit of data in a message queue that just happens to be there for a short period of time. But then you also have your OLAP databases for business intelligence or data warehouse.
Yes.
So with your work on the LLBLGen Pro product today, what do you see as the biggest challenges that our industry, as much advances and options that we have, those problems still aren't figured out, or those solutions are still not widely known?
Well, I think that the products and solutions that are offered today are pretty sound, but the developers who are using them don't fully grasp what the concept of consistency is, for instance. Like the example you had with the queuing, what's the state of the application? If I look at the queue, it has to be stored somewhere. So probably the current application state, if I want to query something, does this order have, has it been shipped yet or not? I have to look into some projection of the processing of the queue. So I think that's still a challenge for a lot of developers. That what's the difference between eventually consistent versus the more tight consistent systems, where you know that if you do a write to the database, it is there, and if I query it afterwards, I will 100% get the value I just have been written to the database back.
Mm-hmm.
And a lot of people assume that if they use Mongo, for instance, they store it in the database and they will read it back and it will be there. But that doesn't have to be the case. You can be redirected to a clone in the network, and then you get stale data.
Mm-hmm.
But it's not really stale data. I mean, it will get there eventually. It's just your change hasn't been replicated yet to that replica. So,
right.
It's I think that's the biggest challenge that we as an industry still have to solve. Those basic principles that what is consistency, and if you understand what the different consistency levels mean, which consistency level do I need for my application? Because not every application needs the most strict consistency level. I mean, if you just store data all day and you will look at it in a week, you don't need to have very strict consistency levels. You can just dump it in a file, in a text file, for instance, and just, it doesn't have to be consistent right away because you'll read it next week. But if you have a very tight processing system, that if a user on a website clicks on something and it persists a record in a database, and the person immediately wants to read it back, it has to be there.
Right.
You cannot say, well, come back in another hour or so. No.
That's right.
So
but at the same time, it could be perfectly fine for it to take a few hours to make it to a different data warehousing database that would eventually end up on a report.
Yeah. That report is maybe run once a week. So it's perfectly fine to store that offsite, maybe even truck it to another company in a truck on a tape, for instance.
Right.
As long as the data is there when you need it.
Mm-hmm.
And that's a concept that I still see a lot of people struggling with.
So there's, you can go on Stack Overflow, any number of places, and you hear debates, and people are throwing around like, oh, do I want to layer on Dapper or any? I hear Dapper being pushed. I hear EF Core being pushed. But there's two styles that I want you to comment on, and with the Dapper model, or going directly against a SQL command, you have a statement, you execute it, you get the result, you're done. But then in the framework, and I think all the OR mappers have this concept of a context or a session or something that tracks entities that have been retrieved. Yes. And you have to manage the life cycle of this little manager object. So what the heck is that, and why does it have to be there in object relational mappers?
Well, we call them entity services mainly. That's mainly you have in OR mappers. You have what Dapper provides as well, like a low layer with where the commands go in and you get results out. And on top of that, you have services that will create those commands and those queries. And based on what do they do that? So they have what's called a unit of work mainly. And the context, what you refer to in a session in Hibernate. And LLBLGen has an object called unit of work. That's basically what it is that you can store work on an entity in there. So like the customer I refer to, if it's new, I can say, well, I have filled in all the fields of that object, and I will now save it to the database. And I will say to the unit of work, well, save this customer for me. But that customer has also made two orders, which are inside that customer object in a collection. And that each order has a couple of order lines, which are also in each order object. So I still say to that unit of work, hey man, just save this customer for me. And it will recursively traverse the graph that was made by the customer in the order object. And it will save them in the right order. Like first, the customer will get the primary key, will sync that with the order object, and will then save that to the database. So that's all been taken care of for you, but the work has to be stored in an object for you. Mm-hmm. So an OR mapper will basically use a unit of work object for that, or the concept of a unit of work. Entity framework and an Hibernate use a combination of their system which generates queries and a unit of work that's joined together into a context for entity framework and a session for an Hibernate. My framework uses a separate unit of work with the engine that will persist it, because with that design you can traverse the unit of work object through your application without the need of having the object that will also access your database with you. Mm-hmm. So some teams, for instance, have developers that are not allowed to talk to the database. So they only can write code to the unit of work object and then send it to a service, for instance, which will pick it up and send it to the database.
I think it's really interesting that the infrastructure has changed over the last couple of decades, where definitely, even 10 years ago, when you said, with air quotes, the database, it was this big, hefty, meaty term that you were talking about. Whereas now, and especially with the new production release of Blazor WebAssembly, in my head, I'm thinking, okay, quote, the database. Well, now if you have a Blazor C# application that's running in your browser in WebAssembly, for all the different things that it can do before it even calls out to a server of any kind, it can do all kinds of stuff. It needs to, it can store and maintain data, quote, the database, now needs to have some representation inside the WebAssembly runtime. And so we need to have patterns to be able to store and retrieve state. And there's got to be patterns or things that we can use in talking to SQL Server or any other kinds of database that can be easily adapted to just storing in some different type of database that's WebAssembly compatible. Are those conversations coming up in your world? Do we have any solutions that you know of that are available yet?
Now, what you describe is basically what we had earlier with the sync framework, if you can remember that. That you had that you could write an application with the Microsoft Sync framework. I don't think it's still maintained, but it was there once in a time on .NET, and you could point it to a local database. And if you didn't have a connection with the internet, for instance, you were in a plane or a train, for instance, and you could simply save the records there, and it will automatically sync up the data that you saved there with the big database when it got a connection live again. I think those kind of solutions will pop up eventually, and the theory is behind it is still the same. I mean, if you use artificial primary keys, like an identity column, for instance, you cannot have the two records with the number 42. So you have to make sure that they are unique locally and in your central database system. Okay, air quote central database. But
and what's your opinion on that? Do you prefer identities or you prefer GUIDs?
Well, my database professor from the university always proclaimed that I have to use natural all the values in the entity definition as one of them has to be unique and identifying. So if you have a customer, then the company name is unique identifying and not an artificial number, for instance. But it's very limiting, because if you have to change the company name, then the identity of the entity instance, the data, changes.
Mm-hmm.
It's like I deleted it and inserted a new one. So if you want to keep track of what relates to the actual record in the database, then an artificial primary key is better. And how to number sequenced primary keys, they are very nice. I mean, it's very easy to use them, and basically the default. But if you have a distributed database with multiple instances, and you have to, for instance, first persist locally and then sync up after a while with something that's in the central service, you get a bit of a problem, because then you have the same numbers, for instance. So there are a couple of patterns for that, like claim a window of numbers, and I will use them, and so no one else can use them, but they're always a bit fragile. So other people will use GUIDs, for example. SQL Server has GUIDs unique identifier support with a feature called comb GUIDs that they will only increase, so they will not ruin your index.
Yes.
Otherwise, they are really unique, so they will cause a lot of disk trashing if you don't do that.
Sequential GUIDs.
Yes.
I think when I looked at them before, I said, okay, how does this thing work? I think it has to do something with the network card. Just and then the system clock, just to try to generate one that's, when sorted alphabetically, would be the next one.
Yeah. It's very clever, but it actually works very well. So you could use that if you really want to have unique primary keys across multiple systems, for instance.
Okay. Well, what's your take on lazy loading? Is it?
Don't use it.
Okay, I love it that you didn't say it depends. That's awesome.
No.
All right, now you said don't use it. Now, in your mind, what are the key reasons that lead you to say don't use it?
I understand why people want to use it. My framework also supports it, but I also have a big switch with that you can switch it off. And basically, it is a mixed bag of performance problems that you will run into if you are not careful. For instance, if I have a grid with customers, I don't know that order example I had with the company name of the related customer of the order. Say I display a grid of orders and the company name of the customer in a separate column. For each order, I have to read the customer entity to get the company name of that order. If I do that per order row, I have per order row a query to the database to get the customer entity. That's called a select n+1 problem, and it will quickly burn down your database if you're not careful. So, but it's very hidden. I mean, you don't see it. You just have a very small piece of code that will ideally pull in the customers. What's wrong with that? Well, everything is wrong with it. So to avoid shooting yourself in the foot, just avoid lazy loading. And there is another advantage. If you don't have a lazy loading, you are forced to think about what data you will pull out of the database. So is it okay to fetch orders and the customer entity and maybe another related entity just to display one grid? Or is it better to formulate a specific query that you project to a DTO, data transfer object, for instance, and bind that to a grid?
Okay. Now, on stateful applications for, like, whether it be WPF or Blazor assembly or Xamarin or whatnot, what's your preferred pattern for how long this ORM cache sticks around? How often do you try to recycle it? Is it every transaction, every button click, or do you let it stay there the whole life of the user's session?
I have a result set cache which the user can configure the way they please. The developer, like if they want to have 120 seconds of caching of a result set or 2 hours, that's up to them. Basically, what I try to tell our customers is when you pull data out of the database, it's stale. So you have to make sure that you realize someone else can have already changed that.
Yeah.
So if you send it to a client, if it's a website or a desktop application, if the data comes back, you have to make sure that you can handle that some rows maybe aren't there anymore or have been changed. So you have to have some kind of concurrency protection in place, like I'm going to compare timestamps or whatever you have. And if you don't, then you will run into problems like, two users overwrite the same data and they don't know it. So,
right.
Of course, that doesn't have to be a problem. I mean, if you have two desktop applications in a company, for instance, and both overwrite the same data, then that might be a sign of organizational problem, that you have to make sure that Bob and Alice don't work on the same data.
Right.
But it's better that you can prevent that. So,
okay. Now, every example out there, every quick start, it says, and of course you're going to use Entity Framework Core, and here's how you'd use it in DB context. But you say that there's life beyond Entity Framework.
There's life beyond Entity Framework.
But, we see, okay, well, of course, all the samples at Microsoft are going to be Entity Framework. What should people be thinking about? When do they use Entity Framework, and when do they use your product, and when do they use something else? What's your best advice there?
Well, if you take a dependency on an object-relational mapper in your application, you have to make sure that you take the right one. And with Entity Framework and other ORMs, they come with their own way of working. But not only that, they also enforce you how to create your entity classes and your database schema and your mappings, for instance. Now, if you really want to just write code first, classes, and then you point them to a database and make tables from that, and okay, good luck. But what I say, the best thing to think about those things is really just define the abstract entity model, like what's a customer, what's a product, what's an order, so you can describe that to your stakeholders for which you create your software. And you can project that to your database and your classes, maybe by hand or with a tool like LLBLGen Pro, which does that for you. And if you then decide to use Entity Framework as a runtime or our ORM as a runtime, you can do both because we support both runtimes. But that's really a better way to think about data access when you start than just look at Microsoft and pick their default, because it might not be how you want to work with your database, but then you're stuck. So if you don't look up front what choices you have, you might run into the realization that you made a big mistake. So really look beyond Entity Framework, what's out there. Maybe if you just decide, I want to use Dapper or I want to use another micro ORM, that's fine too, as long as you think about what your need and that what you choose is really how you want to work with it. And chances are that if you pick a micro ORM, for instance, Dapper or Poco or whatever, that along the way you realize that you have a lot more work to do than what you initially thought, because all the entity services I talked about earlier, those things are provided by a full ORM. So it might be better that you look for a full ORM, because you can outsource all that work through those frameworks. And which one should you pick then? Well, make a thoughtful choice. Like, so to recap, think about designing your entity model in an abstract way. Try to project that to tables and classes, preferably with a tool. And then check out which frameworks there are and see how they work and need you, how they enforce you into querying the database, and if that fits your way of working.
Mm-hmm.
And do that up front, because it's very painful to replace an ORM along the way, even though you might be designing your software like, oh, I can replace it in any way. No, you can't. It's really, it bleeds in, like any technology you take a dependency on. For instance,
sure.
If you choose ASP.NET Core, MVC, or Blazor, or Razor Pages, or Blazor, for instance, you cannot change that overnight into a totally different application. So
right.
If you make a choice, you have to stick with it.
Right. Okay. Well, as we wrap up, I want to give you an opportunity to talk about your product and what type of developer and would want to go and check that out and give it a trial run. So, what would you leave us with for who should be looking at LLBLGen Pro? Well,
LLBLGen Pro comes in with two parts. One part is the visual designer, which can deal with our runtime, entity framework core, and Hibernate and link to SQL. And it basically provides you a way to work with databases database first, like you already have a schema, you have tables and store procedures and views. Or it also allows you to work model first, so you can use a simple text DSL to define your abstract model, entities, and what have you, and project that to tables and generate the SQL scripts for them to create them and to update them, and to generate classes and mappings for the runtime framework that you have chosen, like Entity Framework Core or our own runtime framework. Our own runtime framework is fully featured like Entity Framework and Entity Framework Core. It has some more features than those frameworks, and we exist for more than 18 years. So we've collected a lot of features along the way.
Right.
So it would surprise me if you really run into a feature that you think, well, it's a big feature, why don't you have it? So, and it's very performing. We've worked very hard in the last couple of years to make it one of the fastest on .NET. So,
well, I think what's important, what I'm hearing, correct me if I'm wrong, is that while it is a very established and mature product, it adds additional designer and modeling support on top of Entity Framework Core, even if that is their choice.
Yes.
Yeah, that's key. I think that's a key thing, that it's not a either or. It's you're using, if you start with EF Core doesn't provide all those designer and modeling niceties. You're just kind of on your own.
Yeah, exactly. So, and even if you, for instance, think, well, your framework is nice, but I really have to use Entity Framework Core or for whatever reason, you can just change the framework of choice in the designer with one click, generate code, and you're in business. So
awesome. Fantastic.
You can even import your EDMX file from yesteryear and convert it to link to SQL or Entity Framework Core or whatever.
Okay. Now, as we close with any data access technology, you're running your tests that execute your data access, or you're running your full application. What does Frans Bouma do to kind of peek at the actual queries that are being run against the database while running your application to make sure that it's doing what you expect it to do? What's your method of choice these days for that?
Well, a couple of years ago, I've wrote an ORM profiler, which is a free product you get when you buy a license for LLBLGen, which can monitor any query that you execute on a database. So I mainly use that to see what's going on, because sometimes you think, well, I think it executes those queries with those parameters, but it's actually not the case. And sometimes I still use a SQL Server profiler because it will give you more the actual reads, the amount of reads and per query. And I use tracing. It's still very built into .NET, and not a lot of people use it, but it's really a versatile way of logging, because our framework simply writes to a tracer, and you can switch on and off which tracer you want to listen to. And my unit tests, for instance, log their queries they execute to the output using the tracer, and I can just say, those unit tests failed. What did they execute? And I can see right away in the output log what queries they execute. And if I want to look deeper, I'll start Profiler, and then I look into that.
Awesome. All right. Well, thanks for the tip. And hey, thanks for coming on the show. This is a lot of great information that I think every developer needs to hear.
That's fun. Thanks.
Awesome. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.